AnyLogic software and discuss its capabilities. I will first briefly introduce what we mean by modeling and simulation modeling, as well as the difference between these two. Then I will present the simulation modeling paradigms. An overview of AnyLogic and its main characteristics is given. Setting up the software and presenting the environment, menus, and features we follow. Finally, we will see together different steps adopted to implement use case regarding the generation of agents, disturbances, and dashboards for statistics. Modeling is a way we can solve real-world problems. In many cases, we can't afford to experiment with real objects to find the right solutions. Building, destroying, and making changes may be too expensive, dangerous, or just impossible. If that is the case, we can build a model that uses modeling language to present the real system. This process assumes abstraction. We include the details we believe are important and leave aside those we think are not important. The model is always less complex than the real system and is free risk. Computers are powerful modeling tools, and they offer us a flexible virtual world where we can create anything imaginable. Of course, there are many types of computer models, from basic spreadsheets that allow anyone to model expenses to complex simulation modeling tools that help experienced users explore dynamic systems such as consumer markets and battlefields. In almost all major organizations, strategic planning, sales forecasting, logistics, marketing, or project management team, the favorite modeling tool is Microsoft Excel. Excel has several advantages. It is widely available, it is very easy to use, and it allows you to add scripts to your formulas as your spreadsheet's logic becomes increasingly sophisticated. The technology behind spreadsheet-based modeling is simple. You enter the data inputs in some cells, and you view the data outputs in others. Formulas and in more complex model scripts link the input and output values. Various add-ons allow you to perform parameter variation, Monte Carlo, or optimization experiments. However, there is also a large class of problems where the analytic solution is hard to find or simply doesn't exist. For example, nonlinear behavior, non-intuitive influences between variables, time and causal dependencies, all above combined with uncertainty and a large number of parameters. In most cases, it is impossible to obtain the right formulas of a system. Consider a problem that requires you to optimize a rail or track fleet. It is difficult to use an Excel spreadsheet to manage factors such as travel schedules, loading and unloading times, and delivery time restrictions. Simulation model is always an executable model. Running it builds you a trajectory of the system's state changes. Think of simulation model as a set of rules that tell you how to move from a system's current state to a future state. The rules can take many forms, including differential equations, state charts, process flow charts, and schedules. The model's outputs are produced and observed as the model runs. Simulation modeling requires special software tools that use simulation-specific languages. While you will need training to do simulation modeling well, your time and effort are rewarded when your model offers a high-quality analysis of a dynamic system. Simulation modeling has 6 key advantages. 1. Simulation models allow you to analyze systems and find solutions where methods such as analytic calculations and linear programming fail. 2. Once you have chosen an abstraction level, it is easier to develop a simulation model. It typically requires less thinking, and the development process is scalable, incremental, and modular. 3. Simulation model structure naturally reflects the system's structure. 4. In a simulation model, you can measure values and track entities within the level of abstraction, and you can add measurements and statistical analysis at any time. 5. The ability to play and animate the system behavior in time is one of simulation's great advantages. You will find animation useful for demonstrations, verifications, and debugging. 6. Simulation models are far more convincing than Excel spreadsheets. If you use simulation to support your proposal, you will have a major advantage over those who only use numbers. Given these advantages, should we always opt for simulation modeling? The answer is no. Decision depends on several factors. Indeed, it depends on the problem to be addressed, on the type of simulation to be used. In some cases, combined with additional tools such as analytical modeling. It also depends on the level of abstraction, details to be considered and details to be neglected. In simulation modeling, method is a framework we use to map a real-world system to its model. There are three methods: system dynamics, discrete event modeling, and agent-based modeling. Each method serves a specific range of abstraction levels. For example, system dynamics assumes a very high abstraction, and it is typically used for strategic modeling. Discrete event modeling supports medium and medium-low abstraction. In the middle are agent-based models, which can vary from very detailed models where agents represent physical objects to the highly abstract models where agents represent competing companies or governments. You should always select your method after you have carefully considered the system you want to model and your goals. In this figure, the modeler's problem will largely determine how they model a supermarket. They could build a process flowchart where customers are entities and employees are resources. An agent-based model where customers are agents who are affected by advertising, communication, and their interactions with agents and employees, or a feedback structure where sales are in the loop with ads, quality of service, pricing, and customer loyalty. AnyLogic is the only software to have all three simulation modeling paradigms. It provides a set of libraries to model a variety of situations. It allows experiments, optimization, Monte Carlo sensitivity analysis, and custom experiments. We can also model deep reinforcement learning in AnyLogic, and also AnyLogic provides us with the 3D graphics and animation and many more.